All right, so now we are going to jump into the product. So let's take a look. So I'm going to bring us back to the home screen here. So I am in a demo account here, but it is a real customer. And so when you come into your dashboard, you'll be brought into the same place. So what you're going to want to do in here is you will want to head to reports. And then from reports, you're going to want to navigate to the production report, which happens to be the first report that you come to. So I'm going to do some filtering in here. Like all of our reports, there are filters. So the first thing is your shift filters. I'm going to leave on all the shifts, at least for the purposes of this, but certainly when you're using these reports, feel free to use those filters as you need to. I'm going to select the cell 1 group. And what I'm going to assume is that I'm a cell leader who's responsible for, I'm an engineer who's responsible for production on a cell of machines. And so I'm looking to see what yesterday's production looked like in my cell to understand if any of the jobs that ran may have suspect standards. So I'm going to select just that cell. And I'm going to hop in here to the date picker and select yesterday. And I'm going to let this run. Okay. So what we see here is that there are 3 jobs that fit the criteria that I've put in. And so you can see they all ran on different machines, and you can see some of the data. This is just the basic data that I pulled in from here, but know that you can always edit what data items you're able to see. Within here, there is a lot of data. So most customers pare this amount of data back a little bit to just the necessities for their business. So I went ahead and did that for this account, but know that what's important to you may look different than what I have here, and that's okay. But some things that I can see off of this, I can see, I pulled in utilization rate, I pulled in things like OEE and production efficiency, but you'll also see that I have that performance metric. Now that's the one that I said ties to OEE. Now, something that's very helpful to know about performance, and we'll dive deeper into this, but just from this view, I can tell a lot about the job standard without even seeing what the standard was versus the actual. So within performance, your goal is to have 100% performance, which means that you were dead accurate to your cycle time standard. And then if it creeps too high above 100%, it means that you're outperforming your standard. So you're actually planning too much time. And if you're significantly below 100% in your performance, it means that you're not planning enough time and that you're actually shortchanging the job. So what we can see here is these 3 jobs. I have one job that's at 101%. And we're going to go one click deeper, so we'll see kind of the cycle times that were expected. But I would expect when I go into this one that this standard is going to be accurate. I would expect that this standard is going to be too high and that this one is going to be too low. And I'm going to use this to then go deeper into the reports. So from here, I'm going to dive first into the one that I know is pretty accurate to its standard. So when you open up this report, this is now a more detailed view of this job that ran. I can see the job number, I can see how many parts ran, I can see the OEE plus the breakout, but down here I can see some other things. Now this particular job did not have a setup, but if a setup had happened, they would also be able to see setup analytics related to job standards. Some of you have setup standards and some of you have resident setups. So, setup will be relevant to businesses that have setup. But in this case, what I really want to hone in on is this expected cycle time versus the average in cycle time. So this average in cycle time is analogous to median cycle time. So what you have here is a standard of 45.3 seconds, and that they, on average, across the 1,683 parts they made, they were making these parts in 44.8 seconds. So this is an example of where they are very accurate to their standard. There's no need to update here. Their performance looks good. This all looks very the way I would expect for a job that has already had its standards confirmed. So in contrast with that, let's go back a click and let's go into one of the other jobs where the standard was not that way. So let's go into this job where the standard, where our performance number was well over 100%. So when I come into this job, we're going to go to the same place that we were before. And again, this job also did not have a setup time. You can see the number of parts they ran, but here's where we want to focus. They're planning a minute and 40, almost 46 seconds for cycle time. And on average, they're making the parts in 1 minute and 14 seconds. If they don't update this standard, they're off by, you know, a good 30% on their standard, 40%. And so if they say they were running 10,000 pieces like this, they will wind up, you know, basically finishing the job before it's supposed to be finished. Now, that can be, I guess, good in some ways, but what it tends to do is it backs up your production schedule, because then the next job may not be available to run yet. And so having this standard be more accurate, maybe adjusting the standard to 1 minute and 20 seconds or 1 minute and 25 seconds would help them shave that 20 seconds off of their expected cycle time. And let's say that they quote this part. You know, that 20 seconds of cycle time adds cost to the part. And so this allows them to cost their parts more accurately, as well as to have real numbers that they can update from. Now, one other thing that I want to just show really quickly is from here, if I click down here, I can get to some additional information. These 3 little dots that are here, I can actually go into what's called the cycles report. And that's going to show me the cycle times for all 996 parts. So in here, you can see, I can see every part that was produced and its timestamp. I can see the duration of the run. And if I go all the way to the bottom, I can see the total number of parts, the median cycle time, the mean cycle time, as well as the standard deviation. And these statistics can also be helpful in helping engineering know whether they really need to update a standard or if they actually don't need to do that.